Hello. Hello and welcome to this video. In this video, we will cover a bit of theory about objects. There will be few parts of this, probably 2 or 3 parts, because there is a lot of theory to cover. Although we have covered the loops and operators, there are certain loops and operators which we will need to cover. I have not covered those things. For example, I have not covered yield, for in, for off, those kind of things we have not covered, or the conditional property invocation, those things we have not covered. But we will cover those later once we proceed a bit further into objects, arrays, and classes. And then we will look at those missing operators and expressions. So objects is one of the most fundamental entities in JavaScript. So I have written a bit of theory here so that I don't miss it. Let's go through these one by one. So the first point is that an object is a composite value much like C++ or Java's instance of classes. So like C++ and Java have objects, JavaScript also has objects. Like C++ class is an object, it can consist of primitive types like integer, floats, or it can consist of other objects. In C++ and Java or object-oriented programming languages, when we have objects inside objects, we know that as composition, and same here. Now, objects are an unordered collection of properties, each of which has a name and a value. So you can think in terms of, if you want to think in terms of C++ and Java, you have a class and that has data members. For example, int x, that has some value. So the name x and the value, let's say 10, that will make a property. Name and value pairs make property. Now the property names are either strings or symbols. JS objects also inherit properties of another object known as its prototype, which leads to prototype-based object-oriented programming. JS objects are dynamic, unlike C++ Java objects, with the ability to add or delete properties at runtime. JS objects can also be used to simulate static objects like that of C++ and Java. If we ignore the values of properties, we can treat the objects as sets as names of properties are unique. So consider an object. For example, let's say line 29 is an object XYZ. Now the names XYZ would be unique inside an object. So if you ignore the values, this will form a set, because the property of a set is that all the elements of a set are unique. So we can treat an object like a set. Any value in JavaScript which is not a string, a number, a symbol, or true, false, null, or undefined is an object. Even though string, number, and booleans are not objects, they can behave like immutable objects. Objects are mutable in general and accessed or changed by reference. So for example, let's say we have this object O1, okay? And let's say we say that let O2 is equal to O1, okay? And then we say O2.x is equal to, it would be better if we take coordinate. Coordinate 1 is equal to coordinate. And then we say coordinate 1.x is equal to 5. If we do this, then the x of this coordinate will also change, because both coordinate and coordinate 1 share the reference. So it's not that it's a copy, right? Both are pointing to the same object. That's what we mean here, that They are accessed or changed by reference. The value may be any JavaScript value, or it may be a getter-setter function, or both. In this world, non-inherited properties are called own properties. So for example, these objects will have a prototype from object.prototype, but xyz here in this case, or in case of another coordinate xyz, the properties xyz belong to coordinate object. It doesn't belong to object.prototype. So these properties xyz are own property of coordinate. Properties have three other attributes other than name and value. The first property, the first attribute of a property is writable, which specifies whether the value of property can be set. Changing this makes an object immutable. So, for example, you could make this change it in such a way that you can't set the property. In that case, object will become immutable. Enumerable attributes specify if a property name is returned by a for in loop. Configurable attributes specify if a property can be deleted or and whether its attributes can be changed. So one of the reasons why I didn't talk about for in loop when we were discussing loops is because of this reason. So once we have seen that how we can change the enumerable attribute of a prototype, then we will see that how we can use this in a for in loop. There are three ways you can construct an object. One is using literals, the second is using new keyword, and the third is using create function. So these examples which I have created are created using literals. So the first is O1, which is an empty object. The second is coordinate, which we have already talked about. It has three properties, x, y, z, and they are given value of 1, 2, and 3 respectively. Then we have another coordinate whose properties are also x, y, z, but values are computed using the values of coordinate properties. Then we have another object person, which consists of three properties: age, home address, and name. Note that when there is space between words in the name of property, we have to use double quotes so that we can see this. Now we have the home address and we have name object embedded inside person. The name object has two properties, first name and last name. Now you have seen that we can access the property like o1.x, but if it contains a space, then you can't access that. So then you have to use the brackets. So for example, we can say o1x, or in case of person, we have to access the home address like so. You can't use the dot in this case to access home address in case of a space. Okay. So there are two ways you can access. One is using dot and another is using brackets. So these were created using literals. Now we see how objects are created using new keywords. So we can say let O is equal to new object, which is same as the O1 here. We can say let A is equal to new array, which is same as empty array. We have let D is equal to new date, which gives you current timestamp, and M is equal to new map, which is a new object for key value mapping. And then we just print the console log here, where you can check D. So for example, I have done this already in the main case. So if you see, it prints the current timestamp as D. Okay. Now we see how we use the object.create in case this is the third method of object creation. So Every JS object will have a second object associated with them, that is prototype, which I have talked about. So the first object inherits properties from this prototype. So we have seen this new object in new array. So this will inherit from object.prototype and this will inherit from array.prototype. Now, only a very small number of objects have prototype property. These are the objects from which other objects get their prototype objects. So this object is basically one of those objects which has its own prototype property. Object.prototype has no prototype and such objects are rare in JS. Most built-in constructors and most user-defined constructors inherit from object.prototype. For example, date object inherits properties from both date.prototype and object.prototype. This linked series of properties is called prototype chain. So how we can create using create keyword is, you say o1 is equal to object.create, then you pass in an object to this function and a new object will be created. So I have passed a JSON object here. You can pass it an array or date or whatever kind of object you want to talk about. So what is the use of this kind of object creation? So one of the use would be, let's say there is a function f. I know we have not talked about function. Suppose there is a function f. Okay. And we are supposed to pass it o1. All right. And let's say this object is make it. So let's make it o1 is equal to this. Okay. And this is, suppose we want to pass it an object o1 to the function. Okay. But it modifies o1. But we don't want the modification of o1. Okay, we want the code to work, but we don't want o1 to be modified in this function. So what we can do is we can send it o2. Okay, the code will work because the prototype and properties of o1 will be available in o2. So it will work because it has the same properties and same prototype. But the side effect would be that now our o1 will not be modified. Okay, you can't say o2 is equal to o1 because then it will be a reference. If you modify o2, o1 will be modified. So one of the uses of this object.create is to create another object and then we send it to a function which modifies the object. Now, if you don't want prototypes to an object, you can simply pass null. Okay, it will create an object. It is not very useful because you want to do something with the object, and with no prototype, operations would be like very difficult. Okay, consider, for example, an array object. So you can access by brackets or index. You can push value to it. You can remove values from array. But if you construct an array from a null object like this, okay, you won't have properties. So for example, if you want to make this o2 and we want it to have like an array, the best idea would be to create it from an array. Okay, array. So if you want it to behave like an array, you want to send it an array object. You don't want it to have null. If you want to use the methods and properties or functions associated with the array. So I think we have covered quite a lot of theory. I will let you sleep on it. So if you don't get all this in one go, you can try watching the video again, and a lot of this will also become clear as we solve more problems and how we use these theory points into practice. So with time, this will become better and better. So I hope this video you find it useful. And thanks a lot for watching. Don't forget to subscribe to the channel and share the videos and like, because that will ensure that the video reaches to more people, because that's how YouTube algorithm works. Once again, thanks a lot for watching. Happy programming.